Hi, this is Silvia Mazzoni and welcome to the third video in my series on benchmarking HDF5 format. In the first video, you learned about basics of HDF5. In the second video, we benchmarked HDF5 based on data types. In this third video, we're going to be benchmarking based on structure and overall design of your file management. So now let's go to the second benchmarking, structure. How do we manage the data? I've got a lot of data. Okay, so how are we going to manage it? Well, let's take advantage of the hierarchical nature of HDF5 and use the groups, okay? So this is beautiful because it makes it easy for documentation. You could store them by event. Maybe you could store different recordings from different earthquakes. What I've done here is actually for individual recordings, and so it's actually not per earthquake, it's per recording itself, and then in each one of these groups I've got 3 files: the acceleration, velocity, and displacement. Okay, so this was just the easiest way of just grouping. So I have an infinite number of groups. You can group by earthquake, you can group by type, you could group by AT2, DT2, and VT2, or whatever you want, and the grouping depends on your use. How are you going to use the data? Okay, in this case, and there's a million different combinations, I put them as data sets all within one main recording. And then the group name is just the file name without the extension, because that's how they're different. Okay, and so the key is going to be the group name and then the file type. So I want to go to, El Centro recording. Again, I want the acceleration file. Okay, this is nice. What's really nice about grouping is it becomes self-documenting. It's almost like one house, different rooms. Okay, that's how you can store the data. Or somebody like me, all I'm going to want to do is I'm just going to come home and throw everything on the ground. And everything is just everywhere. I have one big room that stores all of my recordings. And so they're all individual files saved as data sets. So this makes it really almost, it's not structured, right? They're not grouped. But maybe it makes it easier for me because I want to search the records based on some attribute. And so this way, I don't have to travel through my different folders. I'm in this folder and I just want to give me all the attributes, all the records that have a DT of 0.05 seconds. Or if I've got other metadata, I can filter on that data, okay? I do want to point out that in this case here that I just mentioned, I can do a filtering or a search based on these attributes. I can do the same thing in the case of grouping where I assign metadata to the group itself. And so this is the case where, typically we think of assigning information or metadata to the records, but this could actually be information. I mean, these are different measures of the same recording. And so maybe here I could put magnitude and distance. And so I can do a search per group based on these attributes of each group. Okay, so it's almost like putting a sign at the door and saying, hey, what's in this room? To query, you just have to think about what you're doing. And so you can just throw everything in one room. For me, it's easier to find things like that than to go into different rooms. The other option is to have different houses. So one house is going to have all the acceleration, one file is going to have the velocity, and another file is going to have the displacement. What does this mean? Okay, if I look at just overall thinking, well, this is almost the most compact way of storing things. This one is the next compact way because I'm just giving, groups and attributes. This, to me, seems like it would take the most space. But what is the advantage of doing this is that I'm dealing with smaller files. And maybe somebody only wants the accelerations, somebody only wants velocity, and somebody only wants velocity and displacement. And so it's a little bit easier to manage the files themselves. Okay, and you're going to find in the benchmarking actually that we do hit a point where this files may get too big and it's easier to deal with smaller files. Okay, and that's part of the benchmarking. You've got to test that for yourself as well. Okay, and so what I found out is, and you'll see in the data, that maybe using small files actually helps, and that's what this test is really about. Okay, so let's get started on it. So here's a simple, I put everything into a single loop here. So I have the 3 cases, whether it's a grouping, I'm dealing with all data sets, or data sets in different file types. And so it's easy, this is just simple code. Here, I'm just dealing with, they all just have different file names. When you're in the loop, if you're in the case of a group, we first have to create a group and then assign the data set to that group. So here we're defining it to a group. Here we're just defining it to the root folder itself. And I'm doing the same thing for the case of different data types. If you want, you can even group within the different data types. So there's just so many different combinations, okay? But this is what I wanted to test. Then I'm going to choose from these three options and maybe optimize that. As I said, I'm pretty sure I removed the compression in my analyses. And here I am, all these, either they go into a group or they just all go on the floor in these rooms. Then I'm creating the data set, and then these are the attributes. Very easy to do. And you can put in more attributes if you want. You can go and query your database and put in some more values. So as I said, very easy to work with HDF5 in Python. I've done it with R and it's just as good. It's just a different semantics. So you just got to learn what the words are in the different languages. So here's my comparison. What I did now is I actually went up to bigger. Okay, I bumped up that my maximum number of files for the writing is up to 100,000 files, okay? Because I've got 273, so I got to make sure that I check that. So let's look at file size. What we're comparing is 82 files, okay? And here they're normalized. So this is compared to 82 files that are all going to be at 1, okay? So first we look at, are they increasing? And that's important to always check. And yes, they're increasing, and it almost looks like they are increasing in proportion, okay? And that's something that you should check. Then what I find out here, and then in the normalize, which tells me it's scalable, is it doesn't matter. The file size, whether I have one file with groups, so that's like additional information, and one file with everything all over, in one root folder, it doesn't matter. It's the same size of, either you have one big room or you have many rooms, it takes up the same space, as well as having 3 instead of 1 smaller houses or rooms that take up the same amount of area, that do the same thing, right? And so this is great. So this tells me that my design of how I want to manage my structure is independent on how it doesn't affect performance, right? If I use groups, this or that, my performance isn't changed. Whether I'm working with 10 files or 100,000. On file size, this is important, and this is valuable information. This is great, okay? This informs me on my design. Now we find something interesting, okay? Now we're looking at write time. Okay, and write time, I told you, is not the end of the world, but it's still a metric. Now something stands out. Let's go straight to the normalized. First of all, yes, it's increasing, and that's good. But now let's look at the normalized. There is something happening here. Okay, if you look at the green case, which is, remember, it's the same amount of data, but this is 3 files versus 1 big file. All of these are all normalized pretty much to the same thing, okay? And there is tiny little differences, but they're insignificant. So what this is telling me is that writing to a big file, whether it's grouped or data sets, becomes inefficient once I exceed, more than 10,000 and some point between, 10,000 and 100,000. So this is telling me now that for file size, it doesn't matter, but my write performance is better to write into relatively small files. It's faster to write to 3 files than to 1 big file. All right, so this is going to influence me. So I wanted to keep data separate because it's good to keep it separate. And this is telling me not only am I not losing in performance, I'm actually gaining in performance. Big deal. This is huge. Okay, instead of opening 1 file, I'm actually opening 3 files, but they're 3 smaller files. And so this is really guiding my design in my application. So that's pretty cool, okay? The last metric that we want to look at is the read time. We've looked at file size, we've looked at write time, now it's read time, which is a very important metric because this is really when you're doing the work. Now, as I've mentioned before, what's important also when you're reading the data is also the time that it takes to do whatever it is that you need to do with that data. I didn't do this with this benchmark test because running 100,000 cases times 3 was just getting out of hand and I had some work to do. So what I've done here is I've only looked at read time, and these are 3 plots of the same data shown in different ways. So read time is a really important metric because this is what affects our performance overall in storing the data. But it could be that the read time is so small compared to the processing time that this may not be an important metric. So again, very important, it depends on the application. So let's take the application away and let's just really look at the numbers, because in the end, maybe if you could save a little bit of time, anything helps. So on the left-hand side, right in this figure, I'm plotting for the different number of files, so from 10 to 100,000, that's 100,000 files here, how much read time we have. I'm doing it for, I'm reading the AT2, VT2, and DT2 files. I'm reading the one HDF5 file that has the grouped data. I'm reading one file that has the entire data in data sets at the root folder. And then I'm reading the case where I have 3 different files. Each one holds AT2, the other one VT2, and the other one DT2. So I've got 3 files for every one of these other files. And it's important because is managing the data in 3 different files affecting our performance in a good way or in a bad way? And that's pretty much what we're doing for all these benchmarking here. So if we look at the very top left, the first thing we learn is that read time increases with the number of files, which makes perfect sense, but it's a good way to test your data. And right away, we see that read time is significantly higher than when you have AT2 files than when you're dealing with an HDF5 file. So it's this chunk of time when you're dealing with my case of 100,000 files, this is 7,000 seconds that you have gained. So that's already something that gives you something in absolute values. First thing we do is normalize it by the number of files. And so what this figure here on the bottom left tells us that reading improves efficiency as you have more and more files. It just kind of gets into the rhythm of things. But honestly, the difference is almost insignificant. I mean, we're looking at tiny little numbers, and this can even be affected by whether you're doing something else with your computer or not. But we definitely see, significant reduction in read time when you're working on an HDF5 file. So now let's normalize this and plot everything as a ratio of read time versus the read time for AT2, VT2, and DT2 files, okay? So now let's compare this. Interestingly, what we want to do is we want to watch, do we group or not? So compare these 2 sets here, and we see that throughout they're pretty consistent. So whether you structure your data in group or into groups or everything there in the root folder, your performance is not affected significantly at all, or it's almost not affected at all. But it's definitely an improvement over reading and processing your AT2 files. If we now look at the case of grouping the data in different files, we see that for a small number of files, this is a little bit of extra work, okay? Because you're really opening and closing, opening and closing. But as your file increases in this way, now you were actually gaining in performance. And remember, we saw this gain in performance even in writing. It's faster to write or read to 3 different smaller files than to be writing or reading for one big file. And that's the gain here. But this change is not as significant as what we saw for write time. So if you have everything lumped in one set of files, you may be okay anyways. And so again, this is something you want to test. But it's significant to notice that there's at least 5-fold difference between reading AT2 files versus HDF5 files. And so it's definitely worth it in just reading the data from there, in addition to everything being packaged in one single file versus many files. Well, we made it through part 3 of our benchmarking HDF5 format series, and now we've done all the benchmarking that we needed to do in part 2 and 3 of this video. So stay tuned for the next video where I'm going to be giving recommendation, doing a summary, and just sharing what I learned from these benchmarking studies, and hope that you can learn from that as well.